Let's take a look at a couple of examples to analyze the limit of the function and distinguish between the limit and the output value of the function. Example. Suppose we have the following graph of function g. This is our x-axis, and then we have our y-axis. Try to be more precise as I can. So the graph of the function behaves like this. We have 1, 2, 3, 4, 5, and the rest of the numbers. And on the vertical line, 1, 2, 3, 4, and the rest of them. So the graph behaves like this. At x equals to 2, you have a hole on the graph, and the graph on the left-hand side is defined this way. At 2, when x is equal to 2, you have a hole on the graph, and when x is equal to 5, you have another hole on 2, and the graph behaves like this. And at x exactly equals to 5, the output value of the function is 1. So this is my function g. This is the given function to us. This is a piecewise defined function, and it has some holes, and there is a jump in the graph. So the question says, first of all, what is the limit of function g as x approaches to 2 from left? Let's take a look at the graph. So here we have 2. X is equal to 2. We're going to get closer and closer to 2 from the left-hand side. This negative sign on top of 2 says, hey, I'm going toward 2 from left. It means that on the graph, I'm getting closer and closer to 3. So the limit of the function as I approach to 2 from left-hand side is 3. Part B, question says, what's the limit of this function as we are getting closer and closer to 2 from right-hand side? What is this limit? What is the y getting closer and closer to? So now here we have x equals to 2. We are getting closer and closer to 2 from the right-hand side. I'm getting closer to 2 from the right-hand side, close to 2. What would be my y value? I'm getting closer and closer to 2 from right-hand side, and my y value is getting closer and closer to 1. Very good. So the other question that you should be asking is, well, I have the limit of the function when x approaches to 2 from left and x approaches to 2 from right. Then what is the limit of the function at 2? What is this? Well, the answer is it doesn't exist. Does not exist. Why? You have 2 different y values. They are not equal to each other. So the limit at 2 doesn't exist. It must be a unique numerical value. So the reasoning is, since the limit of the function as x approaches to 2 from left is 3, and it is different from the limit of the function as x approaches to 2 from right, which is 1. So the limit at 2 does not exist. Let's take a look at another x value and evaluate the limit of the function. X equals to 5 is interesting. Let us try to analyze the limit of the function at 5. D. Question says, what's the limit of the function as x approaches to 5 from left-hand side? Okay, the same process. There is 5. 5 is just right here. Let me erase this. 5 is just right here. I'm getting closer and closer to 5 from left-hand side. So I'm going to get closer to 5 from left-hand side. There is the y. I'm on the graph and my y is getting closer and closer to 2. Okay, very well. It wasn't that difficult to see. What is the limit of the function as I go closer and closer to 5 from right-hand side then? So from right-hand side, as I get closer and closer to 5, the y value on the graph is getting closer and closer to 2. Very good. So if I ask you, what is the limit of the function at 5? The answer is 2, because these two numbers are equal to each other. So the limit of the function when x approaches to 5, either from left or right, it doesn't matter. Both of them are equal to each other. It is 2. So you're going to say that, hey, since the limit of the function as x approaches to 5 from left is 2, and it is equal to the limit of the function as x approaches to 5 from right, which is again 2. So the limit at 5 is 2. Just a quick observation. You might say, hey, then what is this dot here? This is the output value of the function when x is exactly 5. So you're going to write it this way. If I plug in 5 into the function g, the output value of the function is 1. 1 is the output value at x equals to 5. So as you can see, there are differences between the output values and the limit depending on how you define the function.